Okay, so we're going to do a mole to mole conversion. So the first thing that we want to do is we want to make a balanced chemical equation. So let's see what we have. So it starts with calcium carbide. So we have that, and it reacts in the excess of water, and how many moles of acetylene and calcium hydroxide are produced. So let's write that balanced chemical equation. So we have CaC2 reacts with H2O to produce C2H2 and CaOH2. So now we have to balance it. We need a 2 in front of the water. That's all we have. So now we already learned how to interpret this. So we know we have 1 mole of calcium carbide, and we have 2 moles of H2O, 1 mole of C2H2, and 1 mole of our calcium hydroxide. So now, once we know that, we need to find a molar ratio too. So we are given, so let's start with what we're given. We're given 6 moles of our CaC2. We're asked to see how many moles of our 2 products are produced. So yesterday we learned how to do a molar ratio, so that's what we're going to do. So what goes up here must go down here. So this is what we said we are given. So our given goes down here. So we get a molar ratio from our balanced chemical equation. So we have 1 mole of CaC2, and we want to go to each of our products. So let's go to what our first product, C2. So we have 1 mole of C2H2. So you multiply the top divided by the bottom, you have a total of 6 moles of C2H2. We do the same step for our next product. Oop, too far. So we start with our given 6 moles of our CaC2. We put that on the bottom. Now again, what I'm doing right now is called the molar ratio. So that has to go in there. You learned how to do that yesterday in that assignment. So that is what you need to make sure you do. And then we go to our 1 mole of CaOH2, again giving 6 moles of CaOH2. Let's do one more problem for this. So again, find out what we have. Reacts with water to form sulfuric acid. So let's write a balanced chemical equation. SO2 plus oxygen plus H2O produces H2SO4. We need to balance this chemical equation. In order to do that, we gotta have some more oxygen. So we put 2 here, here, here. Okay, so we are given 12.5 moles of sulfur dioxide. And it wants to find out how many moles of sulfuric acid we have. So what goes on top must go on bottom. So we have 2 moles. Again, this is our molar ratio from the balanced chemical equation. This label now cancels out. Going to our 2 moles, H2SO4. Multiply the top divided by the bottom. You get 12.5 moles of H2SO4. You always have to start with the balanced chemical equation in order to do these, and then you can go on to the other part. So let's do a mole to mass conversion. Well, we do the same step we just got done doing. You write a balanced chemical equation. So we read what we have. So carbon dioxide is released in the atmosphere through a combustion reaction with methane gas or natural gas. So now we need to write that. So we have CH4 plus oxygen, because it's a combustion reaction, produces CO2, and the other product that's being released, oh yes, you are correct, water. So let's balance this chemical equation. We're now balanced. And let's convert where it asks us to. So let's see what they ask us to do. So this is write a balanced chemical equation, check and done, of methane. So calculate the mass of methane needed if you have 10 moles of carbon dioxide released. So that is our given is our 10 moles. So we want to start with that. So 10 moles of CO2. The next thing right here is going to be our molar ratio. So we look up here. Oh, we have 1 mole of CO2. That's given. That cancels out. Oh, the labels cancel. And we want to go to methane. So we look over here, 1 mole of methane. Nice 1-to-1 ratio for us. And then we need to go to grams. Okay, so moles here. Moles have to go on the bottom. Same label, 1 mole of CH4. And we're going to use the molar mass up top. Molar mass. So we look at our periodic table. Carbon's 12. Hydrogen's 4. You have 16 grams of methane. Multiply the top, divide it by the bottom, you get 160 grams of methane that's produced from this 10 grams. Now note, there's a diagonal relationship with our labels because they have to cancel out. The label here should be the same as the label in your answer. This is your molar ratio, and this is your molar mass, and those become really important to know. And again, that's from last chapter. So let's do another one of these problems. Okay, start with your balanced chemical equation. And we have our sodium chloride decomposes to form sodium, which is a solid, and chlorine gas. Okay, and we balanced. Good. So, what does it give us? Well, it tells us how many grams of chlorine gas are obtained if you have 3.9 moles of sodium chloride decomposing. So we start with our 3.9 moles of NaCl. Go ahead, molar ratio time. So we have 2 moles of NaCl. And we're going to chlorine gas. We only have 1 mole of chlorine gas. Next is going to be our molar mass of Cl2, because again, cancel those labels out. We find the molar mass is 35.5. We have 2 of those, so it's 71 grams of Cl2. Multiply the top, divide it by the bottom, you get 138.45 grams of Cl2. Again, those labels. So again, molar ratio, molar mass. We see the diagonal relationship in the labels, and what label is here should be the label here. All right, have fun.